Hello, hello everyone. So thank you for taking this class, Math. So welcome to Math 2526. So last class we discussed how to find probability. So we say a basic idea in finding probability is separating or separation. We just separate all into parts. Okay. So or So when we consider some probability for if we when we consider some probability for all people, we need to check each part, right? So we have this whole probability formula. So when we find P probability for this thing happen, PA. So this is for all people, right? So we need to check this part for this B1, and then what is the probability this thing happen for B1. Then we need to check this part B2. Then what is the probability for this thing happen for this part, right? So this formula basically is just to check all people, check each part. Okay. So now let's consider this problem. It says that in this school, we have male, female, so we have this information. 60% are male and 40% are female. Okay. So among male students, we know this information. We say among male students, for those people, so 15% chance have scholarship. So for female, for this part, for female, we have 20% have scholarship. So here we have information for this part, for that part. Then we want to consider the all people. What is the percentage for scholarship in this school? So for all people. Okay. So for such a problem, we can use this formula. We just say PA. So let's say we not put PA. We say probability percentage for get a scholarship. So equal. So we check male students. So those people count for 60%, and for them, this chance is 15%, right? For male is 15%, and for female, for the percent for female is 20%, right? Okay, so we find this is 0.099 and this is 8. Okay, so we say, so for all people, male or female put together is 17%. Okay, so among the 17%, this from male and this percentage from female. So we also can check this question among students with scholarship. So among this 17%, what is the percentage of a male? So such a probability actually is a conditional probability. So we can denote this as among those scholarship people, what is the percentage of male, or what is the chance for male? So such a probability is 0.17, and here 0.009, right? Or 9/17. Okay. So this is just check this part, check that part. Or if we consider situations, we just check this situation or this situation. Or good case, also bad case. Okay. So now let's consider this example. So let's say So in our class, we have 25 students, right? We have 25 students, so we have 25 grades. Now suppose our grading policy is just let you pick your grade. Pick your grade. So your grade is not based on your performance, just based on your lucky. So you will complain such a policy is not reasonable. But I would like to say such a policy is fair. So if you get A or get others a better grade, you will not complain, right? You will only blame yourself. You are not so lucky. Okay, so but anyway, so let's say suppose among the 25 we have 5A grade and 8B or those, and we consider others. We don't care. Okay, so we just focus on grade A or not A. So the question is, if the grading policy is like that, so you prefer the first one to pick up, or second one, or last one, or we say the picking order actually doesn't matter. So does this matter or not matter? Okay. So for this question, so we need to check what are the probabilities that the first one get a grade A, or what are the probabilities that the second one get A. Right? So let's check thus, what is the first one get A? So such a probability is very easy, right? We have 25 grades, only five grades, 5 A's. So this is the chance. If you pick one grade, you get an A, right? So you are the first ones. So for second one, what is the probability that the second one get an A? So for second one, we have this. We know by now we just have 24 grades, right? So first one we have 25, because second one, so here by now we have only 24 grades. Then from here pick one. So what the chance you can get a grade A? So the question is, how many A here? How many A among the 24 grades? So you will say, oh, maybe 4, like, right? If the first one get A, then by now we have only 4A left. But how about if first one do not get A? Then among here, like if first one get B or get C, then we still have 5A, right? So for this probability, the second one get a grade A. So we should have we have two cases. We should have consider two cases. Like so the worst case or best case, or the first one get a grade A, or first one do not get A. Okay, so we say such a probability is equal if first one get A, second one get A is this. If first one do not get A, second one get A is this. So we need to multiply what is the probability this thing happens. So this thing happening means the first one get a grade A, this this, right? So plus, so this case is first one do not get A. Do not get A is, so we have 20 other grades, not A. Okay. So this is, we say, the probability for second one get A, or we denote this A2. Right? Okay. So A2 stands for second one get A. So we can also, so this formula actually this, PA1 meaning first one get A, saying second one get A, first one get A, second one get A. And here first one do not get A, here second one get A. Okay, so the formula looks a little bit confusing, but so from here you can easily to understand. This case, the probability is this 4 over 24 multiply the probability for this thing happen, right? Or 5 over 28 or 24. So this means the first one do not get A. Okay. So we need to compare those probabilities. Which one is big? Okay, first one get A is this. For second one get A. So second one, so here we need a little bit calculation. So there's 25 times 24. And numerator is 20 plus 100, so 120. So we find 120 can be factored as 24 multiplied 5. 24 multiplied 5 is 120, right? So here 25, 24. So cancel 24, we get this 5 or 25. So from here we can say the probability for getting grade A for first one to pick and the second one to pick is the same. So this means the picking order doesn't matter, right? Okay. So in this example, we can say like if we consider something, we should check all situations. Good case or check all cases. Good case or bad case. Typically, in gambling, we need to check all situations. Check good case, bad case. So for gambling, a typical question is the game fair? So how can I determine fair or not fair? So the first, let's check a fair game. Like if we toss a coin, so toss a coin, so face up, face down. So if face up, you can win $1, or I give you $1. If face down, you give me $1, or you lose $1. So we put all situations, we list all cases. So you can win $1, or you can win negative $1. So it means you lose $1. And the probability is half same. So we say this game is fair, okay? Because it's balanced, right? So if I change the policy, if I say when you win, I give you $1. Let's see, when you win, I give you $1. Face up, I give you $1. Face down, you give me $2. So in this case, if the policy like this, then you will complain, oh, this is not fair, right? Not fair, not fair. So the probability for this case is half or 0.5, 0.5. So this is not balanced, right? So this is not fair. Okay. So in general, fair or not fair balance means like this number 1 multiply half the probability for this thing happen, plus this number can be -1, or this -1 means you lose $1. So this number, this thing, then multiply this thing, the probability for this thing happen, right? So we find this is 0. So 0 is balanced. So, okay. So this number, such a number is important. So in general, we introduce this notation. Okay. So here, if we list all cases and the probabilities for each case, so in such a table, we call this such a table as distribution. Okay. So distribution is just list all cases along with all the probabilities, right? And from such a distribution, we need to define this numbers. This x, the numbers multiply the probability for taking these numbers. Okay, so this value is called expectation. So we denote as x, and this x we call this a landing variable. X is landing variable. So variable means can change. Like x can be this number and can be that number. Landing means we don't know which number it will take. Sometimes this number, sometimes that number, right? So by chance. Okay. So now we can define a fair game. So a fair game, what is a fair? What fair means here? Means if the expectation is 0. So if means balanced. Okay. The chance good case, a bad case, balanced. Okay. So now for a given game, we need to check. Suppose like a game for a game, we have this decision. We have this rule of win or lose. So when we have a game, we need to find the expectation to determine whether this game is in favor for me or in favor for others, or fair or not fair. Okay. So now let's consider this game. So I just let you, let's say from 52 cards, I let you pick one card, right? From 52, pick one. Okay, pick one card from 52. So if we get an ace, I give you $10. So otherwise, you give me $1. So we want to find, now is this game fair, or is this, so we want to find your expectation. So we just focus on so the money you can win, or we put X, the money you can win. So this X stands for the landing variable for the money you can win. Like, so you can win $10, you may win $10, or you may lose $1, right? Okay, so we also need to find the probabilities for those things happening. So x equal 10 means you get an ace, so I give you $10. So what is the probability you can get an ace? So we say such a probability is easy, like among 52 cards, we have 4 aces, right? So this is the probability you can win $10. And then you will lose, is the probability that's 52, so here 48, right? We have 4 A's and 48 not A's, other cards. Okay, so once we have this table or this distribution, so we can find the expectation. So X equal, so according to the definition, equal, we put okay, equal 10 times 4 over 52, right? Plus, so negative 1 times 48 over 52. So we find this number, so this is a 52, so here's a 40, here's a negative 48. So we find this is equal negative 8 over 42. So this is negative, less than 0. So we can say, for finding expectation is just a negative 8 over 52. Right? So this negative means this game is not fair to you. This game is favor to your partner. Okay. Okay. So let's say, so sometimes we want to determine a fair game. So let's consider this problem. Let's say here's from 52 cards. This time I pick 52 cards. Pick 2 cards. I let you pick 2 cards. Pick 2 cards. And so if you get a pair, you will win. So I should give you some money. So if you do not get a pair, you will lose $1. You give me $1. So the question is, if this game is fair, what is this X, or how much money I should give to you? Should I just need to give you $10, or $12, or $1? $1 definitely not, right? So how much? What is X here? How much money I should give to you? So to get a balance, to make the game fair. Okay, so we need let's use a table, right? You can win X dollar, or you can win negative $1, right? So there's a probability for this good thing or bad thing happen. So for good thing is you get a pair. So we need to find this probability that you get a pair. So for such a probability, because we just pick 2, right? So we can consider 1 by 1. We can use 1 by 1 method. So 1 by 1. So first car, we just pick any car. First car, you just pick 1. See? To make sure you get a pair, you just guarantee the second one and the first one the same, right? Same points. So let's say for second one, totally we have 51 cards. Okay. So let's say, so in order to make sure the second one and the first one the same, so how many cards we can pick? So let's say, suppose the first one you get a king. Then by now we have how many king left? 3, right? So if the first one is ace, then second one, by now we have 3 ace left. So this is your probability that you get a pair. So we can simplify this. So this equals 3 over 51, or 1 over 17, right? So we can put it to here. So 1 over 17. So this is the chance this thing happen. You get a pair. So this thing do not happen. You do not get a pair is 17, so here should be 16. So why? Because we say, so all those probabilities, add them together should be 1, right? 100%. Or this thing, is this thing happening or is that thing happening, right? So from here, so you can easily find this x to be balanced. So this 1, this x 1, here 116, so this x should be 16, right? So when you win, I should give you $16. So if I only give you $15 or less than $16, then you can complain. This game is not fair. I should give you more, right? Okay. So how can we get the 16? So we say, oh, from here, from table balance, we can find. Also, we can use the definition. We say if the game is fair, then x equals 0. So how can we find the x? So this x stands for this x. So we call this random variable. Okay. So and this x is unknown variable. So this x equal, you can win so much money. Then multiply the probability you can win, plus you will lose $1, multiply the probability that you will lose. Okay, so we let this equal 0, we find x equals 16, right? So x equals $16. Okay. Okay, so for a game, you want to have a try or not try. This depends on whether the game is fair or not fair, or whether the game is in favor of you or not in favor of you. So for example, like here, this problem, like it says, in a bag, there are $21 bill. We have a $20 bill and a $50 bill. So here we have a $1 bill, $1, and we have $20 bill. We have 5 $20 bill, and we also have a $50 bill. Okay, we have 1. So you give me some money, then I let you pick 1. So I charge you $15. So give me, so I say, give me $15. Then I let you pick 1. So if you good luck, like if you pick a $20 bill, you can make some money. You can win $5, right? You can get $5. If you get $50, then you can you can make $35. So if you get a $1 bill, then you lose $14, right? Okay. So for this problem, so we just check. We forget to use this $15 you paid to me. I just say pick $1. So how much money? So what is we want to find expectation. How much money you can pick? So you may pick $20. You may pick a $1 bill, $1, or $20, or $50, right? So this, let's say I put the money you can pick. You may pick $1 or $20 or $50, right? So also the probability for this thing happen. So you get $1. So such a chance 20. We have 20 bills for $1. Totally, we have 26 bills, right? 20 plus 5 plus 1. Okay, so if you get a $20 bill, so such a probability is 5 over 26, and here is 1 over 26. So among 26 bills, only one is for $50. So we can find the expectation. We can find expectation. So this expectation, we also can understand the average. You can pick 1, you can pick 50, or you can pick 20. So the average is equal just 1 times 20 over 26 plus, so you can get 25 over 26 plus 50. 50 multiply the probability success. Okay, and so we can do some calculations of this. Equal 26. Denominator 26, numerator is 20, like 1 times 20, so 20 times 5, 100, and 50, so this is 170, right? So this is the money you can get on the average. So I'm sure this number is less than 15. So this means the money you can get and the money you already paid off is not balanced. You paid off, the money you paid is larger than the money you can get. So this game is not fair, not in favor of you. So you should not try to play this game. Okay. Okay. So we say in many of our daily activities, we can regard those gambling games. So for example, like for lottery. So for the advertising lottery company always make this such a advertisement. They say, oh, you just need to spend a little bit of money, then you have a good chance to get a big money, right? They always say that. So here we want to check mathematically. We want to check it is worth to buy a lottery ticket. So this is like you just need to spend $3, okay, to buy a ticket. Okay, so suppose like, okay, so you spend $3, you may win 100 or so 100 or 1,000. You may win the first prize, or you may win the second prize, which is $100. So they will say you just need to spend $3, then you can have the good chance to get a $1,000 or $100. Okay. So here, it sounds good, but but we need come down. We need find the expectation of your purchase. Okay, so here we also can consider like this. You can, let's say, we just check how much money you can win. So you can win $1,000, right? Or you can get $100, or you may win $0, right? Win nothing. So we also need to find the probabilities for each case for those things happen. So you get $1,000, such a chance is it says among 1,000 tickets, only one for this first prize. So this means the probability to get this is 1 or 1,000, right? Among 1,000 tickets, just one ticket for this first prize, for this $1,000, right? Okay, so for second prize, so among 1,000 tickets, there are 10 second prize, 16 tickets for second prize. Okay, so then the chance you can win 0 or win nothing is, so we want to make the all probability together is 1, right? So here 1, 10, 11. So I think here should be 989, right? Plus 11 become 1,000, yes. Okay. So from here, so we can find the expectation. Okay. So W equal, so 1,000 times 1 over 1,000 is 1, and 100 multiplied 10 is 1,000. So over 1,000 equal also equal 1. So here's 0, right? So this number is 2. So this 2 is the money you can get. On the average you can get. So you spend $3, so we can say the net, your net, so we want to find the expectation of your purchase. So we consider the expectation for your net gain. So net gain equal -1, right? So this means you will lose, on the average, you will lose $1. Okay. So this -1, this is this expectation, we also can explain this way. So let's check how much money our dealer can make. Let's say the dealer's profit, or the dealer can make, how much money they can make from this lottery. So we can find their income is from the tickets. So one ticket is for $3, and 1,000 tickets, we assume they are all sold out. So 1,000 tickets, then the money they can income is $3,000, right? So this $3,000 is the money they come from the tickets. So then they need to spend out for those prices. So they need paid out for first price, which is 1,000. Then they also need to pay out for second prices. So second price, they have 10 second price, and each one is 100. So this is also another $1,000. So this equal $1,000, right? So the dealer can make $1,000 for this lottery. So where does money come from? From each ticket, right? So on the average, this means that on the average, each one contribute so much, right? Or contribute $1. So this $1 is you contribute, you give this $1 to the dealer. So this means that this is where the negative, this means just this -1. Negative means you pay out $1 on the average. Okay. Okay. So this is an example for lottery, right? So lottery is a game, and also with many activities, we can regard them as games, like car insurance. So we just pay some money to buy the policy, right? So for insurance company, so sometimes they need to pay out, right? Or sometimes they don't need to pay out. Okay. Okay. So for this problem, so for insurance company, the first question is how to set the premium. So they want to make sure the premium is not so low. If they are paid out too much, then the company will lose money, right? And also maybe they should not set this very very high, then nobody will buy their insurance policy. So they wanted to set a good premium, not too high, not too low, right? So reasonable. They want to make some money, but they cannot. They don't want to lose money, but they also cannot expect to make lots of money, right? Okay. So now let's consider this problem. So for insurance company, so if so they need, we just check how much they need to pay out. So it says if a big major car accident, serious car accident happen, then the insurance company should pay so much, $15,000. Or say if a minor accident, they should pay $2,000. Okay. So the probability for those things happening, says probability is 1%, 0.001, and this is 15%, 0.150. Okay, so we can find their expectation, expectation for payout or payout equal, so just equal this number, multiply the probability for this thing happen, right? And this number multiply the probability for this thing happen. So we find this equal, let's see. So this equal 150 plus 300, right? So equal 450. So this $450 is the average the company should pay out for each car. So the minimum premium should be this. Should be this. At least this. So if they set this, then the company will just make even. No gain, no loss, no payout. So usually they will set a little bit higher than this, then they can make some money, right? Okay. So such a problem we also can consider this way. Let's say the probability is just a percentage. So by the way, where those numbers come from? So this probability is not calculated. It's based on previous record. Like they say, a probability for this thing happens about 1%, means like among 100 cars, maybe there's those major car accident will happen one time among one. So we also can consider like this way. Among 100 cars, we have one car. This thing will happen. A big car accident happen, right? And we have 15 cars. Those minor car accident will happen. Then remaining car, so other cars, no car accident, right? So the payout for this car, then the payout is so much, right? And for those 15 cars, they should pay out 15. That each car they should pay $2,000, right? So this equal 30,000, right? So totally they should pay 15,000 plus 30,000. So plus 30,000. So they need to pay 45,000. Right? So on the average, divided by 100 cars, right? So for average, like it seems for each car, they need to pay so much. So this is their minimum premium. Okay. Okay. So this is expectation. So we say find expectations very important. So from a distribution, we need to find them. So with again, so a distribution is just a list of all cases. So let's say, like suppose we have such a problem. So give the distribution for something. So for such a problem, you need to list all cases and also the probabilities. Okay, probability for each case. So here, let's say here landing variable x. So what x stands for here? So this x. This x is the number of boys. So the story is okay. So in this family, we have 2 boys and 1 girl. We have 3 kids. So from here, pick 2. So this x, the number of boys, can be 1 boy, 2 boy. Cannot be 0 boy, 3 boy, right? So this x can only be 1 boy or 2 boy. Okay. So then we also need to find the probabilities for each case. So what is the probability for x equal 1 or 1 boy? So 1 boy means you get 2, so 1 boy. Oh, let's check this. 2 boy means first one boy, second one also boy, right? So pick first one boy, 2 over 3, right? First one boy. So second one is a boy. So if we first one pick a boy, then by now we have 1 boy, 1 girl. So second one also boy, so the 1 over 2, right? So this equal 1 over 3, right? So if this is 1 over 3, I know this here should be 2 over 3 because add them up should be 1, right? So certainly we can find the probability for x equal 1 directly. So 1 boy, so this means 1 boy one girl. Could be the one boy, one girl. Could be first one boy, second one girl, or could be first one is a girl, second one boy, right? Okay, but anyway, so for such a problem, give out the distribution for this x. So meaning you should give me such a table. So you need to list all cases and also their probabilities. So from this such a table, we say that this number is important. So expectation. So this number, we call this number expectation in gambling probability. But in stats, we call such number as mean. So mean is just the expectation. Mean is just the average. Okay. So we also from this such a table, we also can define another important number. So we call this as variance. Okay. So variance, this word comes from vary, means change. So we use this number to measure changement. Okay. Okay. So for a given distribution, we can find its mean and variance. So like here, we find mean and variance. Okay. So this is just some calculation according to the definition. So let's say mean. Let's say x is mean. So equal. So we can understand expectation E as average. So x can be 1 and negative 1. So the average is, so according to definition, just equal x can be 1, then multiply the probability for taking this number, probability 0.6, and plus x can be negative 1, then multiply the probability for taking this number. So we find this equal 0.2, right? So we can say the mean is 0.2, and this mean in stats actually we denote this as mu. We reserve this mu to for the mean. Okay. So let's say, so for variance, let's check Vx. So Vx equals this x minus mu squares average. Okay. So here in this example, so here mu is 0.2. So this equal x minus 0.2 squares average. Okay. So here x can be 1 or negative 1, right? So x minus 0.2 square can be 1 minus 0.2 square. Okay, so the expectation is this value, so multiply the probability, this x, so this take this value, so meaning x taking 1, so the probability is 0.6. So plus x can be negative 1. So x minus mu can be negative 1 minus 0.2 square multiply 0.4, right? Then we just need a little bit of calculation. So we can put this into calculate. There's 0.8 square multiply 0.6, and then here's 1.2 square, right? Multiply 0.4. So use calculate, we can find this number. So this number is variance. Okay, so in this class, we introduce this notation, distribution. So distribution is just list all cases, right? So x can be this case, or x can be this number, that number, and also the probabilities for each case. So probability for each case can happen. Okay, so from such a table, we can check the expectation. Expectation is just check whether check all situations. Consider good case or bad case. So in gambling, if this number is positive, means consider good case or bad case, we can win some money. So this is good for us, right? So if this number is negative, means consider all situations, check all case situations are balanced or odd, we find we will lose money, right? So if x equals 0, means we will not lose, not gain. So this is fair to us and to our partner, right? So if this game is fair, that x equals 0, then I win some money, means I'm lucky, right? Okay. So also from this a distribution, from a table, the distribution, we can introduce this. We can define the two important numbers: mean or expectation, and variance. Right. So the definition for variance, we can regard variance is average for those things, and mean is average for x. So average for x equal mu, and this variance, we also have a notation, we call this the sigma square. Okay, so those two numbers is important. Okay, so this is today's class. Okay, so we can stop here, and thank you for watching.